Hey there, Mr. Weaver here, and this is Topic 9, Lesson 5, Solving Quadratic Equations by Graphing. After this lesson, you need to be able to identify the zeros of a quadratic function from a graph. You need to be able to solve for x in a quadratic equation by graphing. And you need to be able to identify the binomial factors that were used to create a quadratic graph. You'll know you're successful after this lesson if you can identify the solutions from a graph, solve for the variable by graphing, and determine the two binomial factors that were used to create the graph based on what the zeros are. Graphing is our fifth method that we have seen where we can solve for x when it isn't a quadratic function, or solving when it's x squared. So if it's already graphed, you just need to identify the zeros. If it's not graphed, we can use Desmos. What you're looking for, you're finding the x-intercepts, or where it crosses the x-axis. Most times it will cross twice. Sometimes it will just touch and only be on the x-axis once, and other times it won't cross at all, which is where you would have no solutions. So let's look at how this works. We have 4x squared minus 3x minus 27. If we're solving by graphing, we go in to Desmos, and here is just a small screenshot of it. You are looking for the places where it crosses the x-axis, which are those two dots there. If you click on the line, those dots will show up. Those are your solutions. In fact, you can click on them. So in this case, our solutions are x equals negative 2.25 and x equals 3. Make sure you are clicking on the correct dots. There is also the vertex and the y-intercept. You're looking for the x-intercepts. So now it's your turn. Pause the video. Solve this quadratic by graphing and using Desmos. Let's check. You should have got your solutions as x equals negative 9 and x equals 12. If we graph on Desmos, we have our two dots there, negative 9, 0, and 12. So that's how we get our answers. Now let's look at an example where it's already graphed for us. So we just need to identify the solutions. The solutions again are where it crosses the x-axis. So we have two dots, two places where it crosses the x-axis. What are those places? It crossed at negative 1, 0 and 4, 0. So x equals negative 1 and at x equals 4. Those are your two solutions for this quadratic. Now it's your turn again. Pause the video and identify the solutions from this graph. Let's check. You should have got x equals negative 2 and x equals 0. Those two places where it crossed are your solutions. In this next example, we're going to kind of use some reverse thinking using the solutions to figure out the equation that might have been used to graph and create this parabola. So if we want to know the binomial factors that were used, so that's our two values, in parentheses. If we think back to lesson 2, when we were factoring, we ended up with something like x plus 5 in parentheses and 2x minus 3 in parentheses. Then we set each equal to 0 and we're able to solve for x. Here we're going to go backward. So looking at this graph, there are two places it crosses. It has two solutions. It crosses at x equals negative 4, and it crosses at x equals 3. Those are our answers. If we think about what we did for factoring, we set it equal to 0 and then solved for x. So we're going to kind of undo that. If it was originally set equal to 0 and we solved and now it's -4, we're going to do the opposite. We're going to kind of bring that over to the other side. So now we'll get x plus 4 equals 0. Then if you think about factoring again and working our way backward, before we had set it equal to 0, we just took that binomial. So that x plus 4 must have been what is in parentheses. If you look and work your way up here, thinking about factoring, it was x plus 4, set it equal to 0. We would subtract 4 from both sides. So to determine the binomial factors, we are working our way backward. So let's look at if it was x equals 3. We would do the same thing. First, we would subtract 3 from both sides. So we get x minus 3 equals 0. What was set equal to 0 must have been the binomial. So x minus 3. So those are our two binomial factors, x plus 4 and x minus 3. Now, if you need to go farther and figure out what the actual equation is, you would just take those two binomial factors and multiply them back out. For a review on how to multiply binomials, look back at Topic 7, Lesson 3. Now it's your turn one last time. Pause the video. What binomial factors were used to create this graph? Let's check. You should have found x plus 5 and x minus 2. Here I wrote them as if I was starting to make the equation. It crosses the x-axis at x equals -5 and at x equals 2. So working our way backward, we would add 5. So we get x plus 5 equals 0. So x plus 5 must have been one of the factors. Following a similar process, we would get x minus 2 as our other factor. As a bonus, I want to go through a slightly more complicated example with finding the factors. So a quadratic opens upward and its solutions are x equals -0.75 and x equals 2.25. What binomials could have been used to create this function? So we're going to take what they gave us, work our way backward. Since here we have some decimals, we're going to have to do a little bit extra to figure out. It's not quite as easy as just adding 4 or subtracting 3 like in the last example. First, you're going to write it as a fraction. So x equals negative and then 0.75 is 3/4. Once it's as a fraction, now we can follow a similar process as we just saw to get something equals 0. So here I would multiply by 4 and I'd get 4x minus 3. And then to set it equal to 0, I would just add 3 to both sides. Now that I have it set equal to 0, that 4x plus 3 is one of our binomial factors. For x equals 2.25, again, setting it equal to a fraction. This one's an improper fraction. That's okay. X equals 9/4. Following the same process, multiply by 4, subtract 9. Our binomial factor must have been 4x minus 9. So if we wanted to figure out the equation, we would do 4x plus 3 times 4x minus 9, multiply that out, and we'd have it pretty close. One other important thing when you're actually writing an equation, you do need to take in consideration the a value. So notice here it said the quadratic opens upward. That's important. If you think back to topic 8, when we were looking at features of quadratics, the value of a, that number in front of x squared, tells you if it opens upward or downward and if it's a wider parabola or a more narrow parabola. So if you needed to figure out the actual equation after you multiplied these two binomials together, you would multiply by your a value and get your final equation. In this lesson, we learned about solving a quadratic by graphing, and that involves finding the x-intercepts of the parabola. Without using Desmos, graphing is actually one of the harder, more complicated methods to solve, since you would need to identify a lot of key features, such as your vertex, y-intercept, maybe your zeros by factoring first, which in that case you should have just solved by factoring. So graphing can get a little complicated, but with the help of Desmos, it's fairly simple. Graphing can also help us to determine what binomial factors that were likely used in an equation. To do this and find those binomial factors, you would unsolve, essentially, for the variable until you get your binomial equals 0. So for example, if you found the solution using Desmos was x equals 0.4, after you change 0.4 into a fraction, 2/5, you would multiply by 5, then subtract 2. That way you have 5x minus 2 equals 0. 5x minus 2 would be your binomial factor. Finding the factors can be very helpful and a good starting point if you need to write an equation from a graph. However, those binomial factors aren't all you would need. You do also need your a value to get the true equation, as that tells you how wide or how narrow your parabola is and if it opens upward or downward. So, after this lesson, do you now know how to identify the solutions from a graph, solve for the variable by graphing, and do you know how to determine the binomial factors that were possibly used to create the graph based on what the zeros are? If you're not sure about these things, go through, look at some of the examples, and see if you can figure out some patterns of how they work. And that's the end of Lesson 5 on solving quadratic equations by graphing.